In 1982, a sponge diver named Mehmet Çakır was working the waters off the coast of Turkey near a rocky headland called Uluburun. 50 feet below the surface, he saw something that didn't belong there. Shapes in the sediment, flat, four-cornered forms, stacked like bricks, covered in 3,000 years of ocean floor. He reported it to archaeologists. They sent a team. Over 11 excavation seasons, they pulled 17 tons of artifacts from the seabed. The largest single item in the cargo, 348 copper ingots, 10 tons of copper. Each one shaped like an ox hide, a flattened rectangle with four corner handles, the standard shipping form of the late Bronze Age. Lead isotope analysis confirmed a Cypriot origin. Case closed, or so it seemed. Because here's the detail that doesn't fit the conclusion. That copper, pulled from a shipwreck off the coast of Turkey, dated to 1300 BCE, officially attributed to mines in Cyprus, is 99.5% pure. And copper smelted from ore, which is what Cypriot mining produced, does not come out at 99.5% purity. Not with Bronze Age technology, not with the furnaces they had, not with the techniques that have been documented. There is only one known source in the ancient world that produces copper at 99% purity or above without smelting. A source where the copper exists in raw metallic form, ready to be worked directly from the rock. Lake Superior. This video is about a scientific argument that mainstream archaeology hasn't fully resolved, about a purity percentage that shouldn't exist in Bronze Age metalwork, about what isotope analysis can prove, what it can't prove, and what it leaves dangerously open, and about whether 10 tons of copper sitting in a museum in Turkey might be, in the most extraordinary way, evidence of the most improbable trade route in ancient history. Before we get to the shipwreck and the controversy, you need to understand the tool at the center of this argument: lead isotope analysis. Here's how it works. All copper ore contains trace amounts of lead. Not much, just parts per million, but enough to measure. And lead comes in four stable isotopes: lead 204, lead 206, lead 207, and lead 208. The ratio of these isotopes in any given ore deposit is determined by the geological conditions under which that ore formed, the age of the rock, the type of rock, the chemical environment during formation. Every copper deposit on Earth has a slightly different isotope ratio. And here's the key. When you smelt copper from ore, the lead isotope ratios transfer from the ore to the metal. The smelting process doesn't change them. That means you can take a Bronze Age copper weapon, measure its lead isotope ratios, and compare them to a database of ore deposits from around the ancient world. If the ratios match a known mine, you've traced the metal to its source. This is lead isotope provenance analysis. It's been used since the 1960s to trace ancient metals. It's the foundation of most Bronze Age trade route research, and it's the reason mainstream archaeology attributes the Uluburun copper to Cyprus. But there are two problems with applying this method to Lake Superior copper. Problem 1. Native copper. Lake Superior's copper is not ore, it's metallic copper, pure copper that formed in the rock through a unique geological process existing in nearly pure metallic form without any smelting. Native copper doesn't carry lead in the same way ore does. Its lead isotope signature behaves differently, and the signatures across the Lake Superior basin overlap so much, as a 2024 study in the journal Archaeometry confirmed, that you can't even reliably distinguish one Lake Superior deposit from another using this method. Problem 2. Purity. When you smelt copper from ore, even the best Bronze Age smelting, you produce copper that retains impurities: sulfur, iron, arsenic. The better the smelting, the lower the impurities. But there are physical limits to what a charcoal furnace at Bronze Age temperatures can achieve. Consistently reaching 99% plus purity through Bronze Age, smelting is, according to metallurgists who have studied the question, at the extreme edge of what the technology could do. Some say impossible at scale. Native copper doesn't need smelting. It's already there, at 99 to 99.9% purity, sitting in the bedrock of Michigan, waiting to be hammered into shape. These two facts, the lead isotope limitation and the purity threshold, are why the Uluburun copper hasn't stayed neatly in the solved category. Now let's look at the shipwreck itself, because once you see what was on that ship, all of it, not just the copper, the question stops being theoretical. The Uluburun ship was, as best as archaeologists can reconstruct, a Canaanite merchant vessel. It sank around 1300 BCE, probably returning from a trading voyage along the Anatolian coast. It went down in deep water, 50 to 60 meters, and the anaerobic conditions of the seabed preserved its cargo almost perfectly. When excavators finished pulling it apart over 11 seasons of diving, here is what they had documented. Cargo from at least 7 distinct civilizations. 10 tons of copper ingots in the standard oxide form. 1 ton of tin ingots, tin being the other ingredient required to make bronze, sourced from mines in Afghanistan and transported thousands of miles. Ebony logs from sub-Saharan Africa. Elephant and hippopotamus ivory. Glass ingots in cobalt blue, turquoise, and lavender. Raw material, not finished goods. Canaanite amphorae still containing traces of terebinth resin. Egyptian gold jewelry. Mycenaean pottery. A scarab bearing the name of Nefertiti. Weapons. Merchants' seals. This was not a ship carrying goods from one city to another. This was a vessel moving commodities across the entire late Bronze Age world. A floating sample of the most sophisticated trade network that existed up to that point in human history. And in the center of it all, 348 copper ingots, each one weighing roughly 60 pounds, each one in the same standardized shape, the oxide form with 4 corner projections designed for a human shoulder or a ship's hold. Together, 10 tons. For scale, 10 tons of copper is enough to produce approximately 90,000 bronze arrowheads, or 4,000 bronze swords, or enough bronze sheeting to armor a fleet of warships. The official conclusion: Cypriot copper, based on lead isotope analysis. The ingots' lead ratios match ore deposits in the Apliki mining region in northern Cyprus. But then, there is the purity number, and the purity number is 99.5%. Here is why 99.5% is a problem, not just an interesting detail. An actual, unresolved metallurgical problem. Copper ore is not copper. Copper ore is rock containing copper compounds, primarily chalcopyrite, which is copper iron sulfide, or malachite, which is copper carbonate hydroxide. To get metallic copper from ore, you have to smelt it, crush the ore, heat it with charcoal to extremely high temperatures, and chemically reduce the copper compounds to pure metal. Bronze Age smelting worked. It produced copper. Civilizations ran on it for thousands of years. But it had limits. The impurities in copper ore, iron, sulfur, arsenic, lead, bismuth, don't all evaporate during smelting. Some of them bind to the copper and remain. The cleaner your ore, the cleaner your output. The better your furnace temperature, the better your reduction. But Bronze Age technology, running on charcoal, reached temperatures of roughly 1,200 degrees Celsius. Hot enough to smelt, but not hot enough to eliminate all impurities from even the best ore. Modern industrial electrolytic refining, the process that produces commercial-grade copper today, achieves 99.99% purity. Bronze Age smelting, even at its theoretical best with the cleanest possible ore, produces output significantly below that threshold. Published metallurgical studies on Bronze Age copper production consistently document output purity in the range of 97 to 99%. The higher end requires exceptionally pure ore and optimal smelting conditions. 99.5% at scale, 348 ingots, consistently, all from a single cargo, sits at the absolute limit of what Bronze Age smelting technology can explain. Some metallurgists say it's possible. Others say it's not at that scale with Bronze Age methods. The debate is real. Now here's the thing about native copper. Native copper, the metallic copper found in the Keweenaw Peninsula of Michigan and on Isle Royale in Lake Superior, requires no smelting at all. It exists in the rock as pure metallic copper, formed by geological processes over hundreds of millions of years at purities from 99 to 99.9%. This is documented. The native copper of Lake Superior has been analyzed repeatedly and consistently, comes in at or above 99% purity. It is the highest purity natural copper deposit identified anywhere on Earth in any era. The argument advanced by researchers like J. Stewart Wakefield in his book Rocks and Rows, Sailing Routes Across the Atlantic and the Copper Trade is precisely this: that the only physically consistent explanation for 99.5% purity in Bronze Age ingots at scale is native copper, and the only known source of native copper at that scale, in that era, was Lake Superior. The mainstream response is that the lead isotope analysis points to Cyprus, and that is correct. The ratios do match Cypriot ore deposits, but native copper and smelted copper behave differently in isotope analysis. The 2024 Archaeometry study found that even within the Lake Superior Basin, lead isotope analysis cannot reliably distinguish one native copper deposit from another, which raises a further question. If the method is unreliable for native copper source differentiation within a single basin, how confident can we be that its results hold for a cross-ocean comparison against a completely different type of copper formation? That question has not been answered. Let's step back from the chemistry for a moment, because even if you set the purity argument aside entirely, there is a second problem, a scale problem, and scale doesn't lie. Here is a fact that archaeologists acknowledge openly and have not fully resolved. The Bronze Age in Europe lasted from roughly 3300 BCE to 1200 BCE. During that time, bronze, copper alloyed with tin in a roughly 9-to-1 ratio, was the primary technological material of every advanced civilization on Earth. Weapons, armor, tools, ships' fittings, building hardware, ritual objects, trade goods. Everything was bronze. Researchers have cataloged Bronze Age bronze artifacts across Europe, the Mediterranean, the Near East, and Egypt in quantities that make the metal supply question unavoidable. And when they attempt to account for where all that copper came from, when they add up the known European mines, the Cypriot mines, the Anatolian mines, the Caucasian deposits, and compare the total against the copper that must have been produced to create the artifact record, the numbers don't balance. More copper was used than the known mines can account for. This is not a fringe claim. Studies tracking Bronze Age copper supply networks in Central and Northern Europe explicitly note that Scandinavian Bronze Age societies were obtaining copper from sources that have not been definitively identified. The Great Orme Mine in Wales, one of the largest Bronze Age copper mines in Western Europe, operated intensively for roughly 200 years and still only supplied Britain and parts of the continental coast. The Alpine mines of Central Europe fed different trade networks. The total, when aggregated, still doesn't fully account for the artifact record. Now consider the Lake Superior numbers again. 5,000 mine pits, 3,000 years of continuous operation, an estimated 500,000 tons extracted. And only a tiny fraction of that copper appears in North American archaeological sites. An unaccounted for surplus on one side of the Atlantic, a documented deficit on the other. The numbers, while rough and contested, are in the same order of magnitude. This is not proof, not even close, but it is a gap that sits in the middle of the debate and refuses to be dismissed with a wave. Numbers suggest a connection. But is there any physical evidence at the mine sites themselves? What did researchers actually find on the shores of Lake Superior? The physical evidence cited for a Mediterranean presence at Lake Superior falls into three categories: tools, pottery, and timing. On tools, the mining techniques used at Lake Superior, fire setting combined with stone hammer extraction, are the same techniques documented at European Bronze Age mines known to have been operated by Mediterranean cultures. Fire setting, heating the rock face with fire and dousing it with cold water to crack the stone, appears in documented Minoan mining contexts in Europe and in the Lake Superior sites. This evidence is weak in isolation. Fire setting is a logical technique that any mining culture could develop independently. The parallel doesn't require contact. On pottery, some researchers have claimed that ceramic fragments found near Lake Superior mining sites share design elements with Minoan pottery from Crete. These claims are disputed. No peer-reviewed study has confirmed a direct link between Lake Superior ceramics and Minoan manufacture. The comparison has been made in popular books and YouTube videos, not in the scientific literature. But here is the timing argument, which is the strongest of the three. The Minoan civilization, centered on Crete, dominant in the Aegean from roughly 2700 to 1450 BCE, was the most sophisticated maritime culture of the Bronze Age. They traded across the entire Mediterranean world. Their ships, depicted in frescoes from the site of Akrotiri on Santorini, were large, sail-powered, capable of open ocean navigation. They had access to Babylonian star charts inherited through trade networks. Their vessels were, according to maritime historians, more capable than the ships the Vikings used when they crossed the Atlantic in 1000 CE. The Minoan civilization collapsed around 1450 BCE. Some accounts say the final political collapse came closer to 1200 BCE, coinciding with the broader Late Bronze Age collapse. The Lake Superior mining activity stopped around 1200 BCE. The overlap is precise. The Minoans were the most capable, ocean-going civilization of the Bronze Age. The Lake Superior copper mining ceased at almost exactly the moment the Bronze Age trading network that could have needed the copper collapsed. Proof? No. The pattern? Undeniably. Let's look at what the most recent science actually says, because in 2024 a study tried to establish the Lake Superior isotope fingerprint once and for all, and what it found is more complicated than either side wants to admit. In early 2024, the journal Archaeometry published a study titled Lead Isotope Analysis of Native Copper Deposits in the Lake Superior Basin, conducted by Peterson and colleagues at Indiana University's Metal Isotope Lab. The goal was to establish a reliable lead isotope fingerprint for Lake Superior native copper, something that could be used to identify Lake Superior copper in archaeological artifacts anywhere in the world, including, implicitly, in Bronze Age European finds. They analyzed 40 samples from native copper deposits across the Lake Superior Basin, using MCI-CP-MS, multi-collector, inductively coupled plasma mass spectrometry, one of the most precise isotope measurement instruments available in modern science. The result was not what the transatlantic trade theorists hoped for. The study found that lead isotope signatures across the Lake Superior Basin overlap significantly. The copper from different deposits, Isle Royale, the Keweenaw Peninsula, mainland Michigan sites, cannot be reliably distinguished from one another using lead isotopes. The author's conclusion: lead isotope analysis is not recommended as a tool for sourcing native copper within the Lake Superior Basin. This finding cuts in both directions, and the debate's participants don't always acknowledge that. In one direction, it means that claims of a specific Lake Superior isotope fingerprint appearing in European Bronze Age artifacts are very difficult to substantiate. If you can't reliably distinguish Lake Superior subsources from each other, you certainly can't build a precise provenance argument for a cross-ocean comparison. In the other direction, it means the standard lead isotope methodology used to attribute the Uluburun ingots to Cyprus cannot be cleanly applied to native copper. The 2024 study is specifically about native copper. Copper that was never ore, never smelted, never went through the chemical processes that the isotope method was designed to track. The Cypriot attribution for the Uluburun ingots assumes smelted copper chemistry. The Lake Superior copper is native. The comparison is not equivalent. The study also noted the reason for the overlap. All Lake Superior native copper deposits formed from the same geological event, the same mineralized fluids, the same narrow geological time window, roughly 1.1 billion years ago. That event created a chemically homogeneous basin. The copper is all, isotopically, the same material. And here is the implication that the study doesn't directly address but logically follows. If the Lake Superior Basin is chemically homogeneous, its aggregate isotope signature might be identifiably distinct from the Cypriot ore signature if someone runs a properly designed cross-comparison. Not the lead isotope method alone, which is what current databases use, but a multi-isotope approach including copper isotopes, sulfur isotopes, and trace element profiling, methods specifically calibrated for native versus smelted copper. That study has not been published. The comparison has not been run. So here is where we actually are. Not where the debate claims to be, where it actually is if you read the science carefully. Let me be exact about the current state of this argument. Established facts. Lake Superior native copper, 99 to 99.9% purity. Documented in multiple analyses, the highest purity natural copper formation identified anywhere on Earth. Uluburun copper ingots, 99.5% purity, documented. 348 ingots, 10 tons, consistent purity throughout. Bronze Age smelting capability, capable of high purity under optimal conditions, but there is an active, unresolved debate among metallurgists about whether 99.5% at scale is achievable with Bronze Age technology from ore feedstock. Lake Superior native copper lead isotope analysis. The 2024 Archaeometry study confirms the method is unreliable for sourcing native copper within the basin. The standard provenance methodology cannot be cleanly applied. The Uluburun Cyprus attribution, based on lead isotope comparison to Cypriot ore deposits. This comparison was made using methods calibrated for smelted copper, applied to ingots, whose purity suggests they may be native copper. The mismatch in methodology has not been publicly resolved. Bronze Age copper supply gap, acknowledged by mainstream archaeology. Known European and Mediterranean mines cannot account for all Bronze Age copper artifacts. The deficit is real. Its source is unidentified. What is unresolved? Whether 99.5% consistent purity is physically achievable from Cypriot ore using Bronze Age smelting. This is a metallurgical question, not an archaeological one, and it has not been definitively answered. Whether the Uluburun copper is native or smelted. A trace element and microstructural analysis specifically designed to answer this question has not been published. Whether a properly designed multi-isotope comparison of Lake Superior native copper against Cypriot ore would show a distinguishable difference. This comparison has not been run. What would close the case? 1. Microstructural analysis of the Uluburun ingots to determine whether the copper shows evidence of ever having been reduced from ore, or whether its crystalline structure is consistent with native copper that was simply melted and recast into ingot shape. 2. A multi-isotope cross-comparison, copper isotopes plus sulfur isotopes plus trace element profiles, of Lake Superior native copper against Cypriot smelted copper using methods specifically calibrated for the native versus smelted distinction. 3. One artifact, a single Bronze Age copper object in Europe with a chemical profile that can only have come from native copper, not smelted ore, geologically associated with the Lake Superior Formation. None of these 3 analyses has been published. The case is open not because the evidence was examined and found insufficient, but because the right examination has not been done. In science, that is a meaningfully different statement. In 1982, a sponge diver found 10 tons of copper on the floor of the Mediterranean, and science said, Cyprus. That conclusion was reached using a method designed for smelted copper, applied to ingots that are pure enough to be native copper, from a civilization whose metallurgical technology is not fully proven to have produced that purity level at that scale. The question was called answered. The tests that would actually answer it were never run. In the bedrock of northern Michigan, 5,000 mine pits sit open in the rain. 500,000 tons of copper came out of those holes over 3,000 years, and the vast majority of it has never been found. 2 gaps, both sides of an ocean, both numerically in range of each other, both unresolved. The copper from Lake Superior and the copper in that Turkish museum are both sitting there, completely inert, waiting for a researcher to run the right test. Not the test that was convenient, the test that's actually designed for this specific question. Until that test is run, the honest answer is, we don't know. And we don't know because nobody has looked in the right way. Not because the answer isn't there. Tell me in the comments, do you think the right test gets run in the next 10 years? And would the answer change how you understand the ancient world? Subscribe, because this series isn't finished. The Minoan ships are next. And the distance across the Atlantic, it turns out, may be the least surprising part of this story.